Hi, in this video, I will be showing you problem number 3 of chapter 11 section 6. Determine whether the series is absolutely convergent, conditionally convergent, or divergent. Sigma, n varying from 0 through infinity, negative 1 to the power n divided by 5n plus 1. First, let's understand the terminologies absolutely convergent, conditionally convergent, and divergent. So, what do you mean by absolute convergence? The series sigma an is absolutely convergent if the series of absolute values sigma absolute an is convergent. It also means if the series is not alternating, if the series don't have signs, all of them are positive, then there is no difference between absolute convergence and convergence. Convergent means absolute convergence in the case of positive terms. They mean one and the same. Only when the terms change sign alternatively, or some of them positive, some of them negative, then absolute convergence means sigma of absolute an is convergent. Now, what is conditional convergence? A series sigma an is called conditionally convergent if it is convergent but not absolutely convergent. Meaning sigma an is convergent. It could be an alternating series. So by alternating series test, you would be able to prove that sigma an is convergent. But if you take the absolute values of the terms, it may not be convergent. So a series is conditionally convergent if it is convergent but not absolutely convergent. By series being divergent, you already know if a series is not convergent, then it is said to be divergent. Right? The given series here is an alternating series because it has negative 1 to the power n on the numerator and then 5n plus 1. Negative 1 to the power n varying from 0 through infinity. So when you plug in n equal to 0, it gives a positive sign. Then when n equal to 1, it gives a negative sign. So that way it alternates sign positively and negatively starting from n equal to 0 going up to infinity. So it is an alternating series. So it makes sense to do an alternating series test. We already established in the earlier problem the two requirements that are needed for alternating series test. So condition 1, we have to show that bn plus 1 less than or equal to bn. This is for alternating series test. So we are going to apply alternating series test. Bn plus 1 less than or equal to bn for all n. That is condition 1. Then condition 2, we are going to establish limit as n approaching infinity of bn equal to 0. So this bn here is actually the numerical part of without the sign of the alternating series. Now here, this is an easy expression, so it's easy to prove bn plus 1 less than or equal to bn. So actually here, the bn in this case is just 1 over 5n plus 1. So if we consider bn plus 1, it's 1 over 5 times n plus 1. N gets replaced by n plus 1 plus 1. So it is 1 over 5n plus 5 plus 1. So 5n plus 6. So it's an easy way of proving would be 5n plus 6 is more than 5n plus 1. So the reciprocal 1 over 5n plus 6 is less than 1 over 5n plus 1. So in the inequality will get reversed if you take the reciprocal. This one corresponds to bn plus 1 and this one corresponds to bn, and this is true for every n. This is pretty much condition 1. This is the way we prove that the sequence bn is decreasing. This also means sequence bn is decreasing. That is condition 1. We proved condition 1. Then condition 2 is to establish that limit as n approaching infinity, limit n approaches infinity of bn is limit as n approaching infinity. Bn is just 1 over 5n plus 1. So it is 1 over a large number, that is 0, which is an obvious condition. So this is condition 2 of the alternating series test. So because both conditions of alternating series test is satisfied, so we can conclude by alternating series test, sigma, the given series, is actually convergent, phi n plus 1. Negative 1 to the power of n over phi n plus 1 is convergent. We proved that the series is convergent. In order to prove it is conditional convergence or not, then we have to see whether it is absolutely convergent or not. So we already know Bn equal to 1 over 5n plus 1. That is the absolute part of this alternating series. So if we take the absolute values of sigma an, sigma of absolute an would be negative 1 to the power n is always 1 when you take the absolute value. That's 1 over 5n plus 1 is absolute of, so this actually means you are taking absolute of an, that is nothing but bn. Okay, so we have bn, and then we will choose another series, and then we will either use limit comparison test or ordinary comparison test. So we can say, I'm going to choose another series. I'm going to call it 1 over n, which is a harmonic series. Or you can consider that to be a p series with p equal to 1. So if you take sigma 1 over n or sigma an, which is going to be a p series with p equal to 1, so it is going to be divergent. A harmonic series, we know already that it's a divergent series. So now I'm going to apply limit comparison test. So I'm going to do an over bn, and then we are going to allow n to approach infinity. That's 1 over n divided by 1 over 5n plus 1, so which is 5n plus 1 over n. That is 5n over n plus 1 over n. That is 5 plus 1 over n. And if you consider limit as n approaching infinity of an over bn, which will be the limit n approaching infinity of 5 plus 1 over n, the spot approaches 0, so it is just 5, which is positive and more than just positive finite number, positive and finite number. So we conclude by limit comparison test, sigma an and sigma bn converge or diverge together or behave alike. As we know, our choice of sigma an being divergent, harmonic series being divergent, sigma bn is also divergent. But what is sigma bn? We initially mentioned that sigma bn is nothing but sigma absolute an. So we can say here sigma bn, which is actually sigma absolute an, is divergent. What does that mean? This means it is not, sigma an is not absolutely convergent. Sigma an is not absolutely convergent. So now if we put together the two conditions that we established, that it is convergent in the first place, sigma an is convergent. Now we are saying that sigma an is not absolutely convergent. It's not absolutely convergent. So by looking at 1 and 2, the series is convergent by alternating series test. The series is not absolutely convergent by limit comparison test. So putting together, we can say sigma an, the given series, which is sigma negative 1 to the power n over 5n plus 1, n varying from 0 to infinity, is conditionally convergent. Hope this video helps.